says solve. Now, just like before where we undid addition through subtraction or subtraction through addition, now we're going to undo multiplication by division. So we want to get that x by itself, but it's being multiplied by 5. And the way we do that is we divide it by 5. And whatever we do to one side, we do to the other. These 5 cancel out because 5 times 5, or 5 divided by 5 is 1. We bring down the x and we end up with a 12. Over here we do the same thing. We're multiplying the p by a negative 25. So we undo multiplication of p by negative 25 by dividing by negative 25. And whatever you do to one side, you do to the other. Because p is equal to a positive divided by a negative. Positive 30 divided by negative 25 is a negative. And then you would reduce this fraction by dividing both the numerator and the denominator by the greatest common factor, which in this case is a 5. And that would leave me a 6 over a 5. So it's a negative 6/5. Then over here, we have a negative 2.1x, which means we're multiplying x by negative 2.1. You undo that by dividing by negative 2.1. And whatever you do to one side, you do to the other. These cancel out. And that leaves you an x on the right. That leaves you a 2.9 on the left. So x is 2.9. Okay, next we have over here x divided by 4 is equal to 3. We undo the division of 4 by multiplying by 4, and whatever we do to one side, we do to the other. These cancel out, leaving me x is equal to 12. Then we move over here. There's a couple of ways we can do this. We can undo the division by 4 by multiplying by 4, and then divide both sides by 3. But there is a trick that if you have a single term with a fraction in front of it, like 3/4 h, equal to a single term on the right, what you can do is you can multiply both sides by the reciprocal of 3/4, which would be 4/3. So multiply by 4/3, or yeah, multiply by 4/3. So these would cancel out, leaving me h is equal to, and that's understood to be over 1. This 3 and this 3, 6 and the 3 are divisible by 3, which gives you 6 divided by 3 is a 2. 3 divided by 3 is a 1. So what you'd end up with is 2 times 4 over 1 times 1, which gives me 8 over 1. Or just 8. There we go. Now we have negative k is equal to negative 15. The way we get rid of that negative is we divide both sides by a negative 1. Or you just flip the sign, that's fine. And k is equal to 15. So negative k is equal to negative 15. So positive k is equal to positive 15. All right, let's try this one. 5m plus 6m is 11m, which gives you 33. Then we undo both sides by dividing by 11. And then you end up with m is equal to 3. Over here, first step is we're going to distribute. 4 times m is, or sorry, 4 times x is 4x. 4 times negative 1 is negative 4. Negative 2 times x is negative 2x. Negative 2 times negative 2 is going to be a positive 4. And we still have negative 12. Okay, after distribution, now we're going to combine like terms. So we say 4x minus 2x is 2x. And then we have negative 4 plus 4. Those simply cancel out. And then next we want to get the x by itself by undoing the multiplication of 2 by dividing by 2. And whatever you do to one side, you do to the other, leaving you x is equal to negative 6. Let's try a little more complicated ones. Now, there is a step-by-step for those of you who like everything written out step-by-step. So you could solve this step 1, 2, 3, 4. Simplify each side separately, isolate the variable terms on one side, isolate the variable, and check. And that's basically what we're doing in written form. So if you want to have a place where you have it written down step-by-step, that's how you would do it. Okay, so we want to first get this negative 6x by itself. So we get it by itself by undoing the addition of 5 by subtracting by 5. Whatever we do from one side, we do to the other. That leaves me negative 6x is equal to 17 minus 5, which is a 12. Then we undo the multiplication by negative 6 by dividing by negative 6. Whatever we do to one side, we do to the other. Give me x is equal to a negative 2. Like that. Then over here, combine like terms. Well, there are no like terms. So we need to get all the variables on one side. You can either get them both on the right or both on the left. So let's say I wanted to get all my x's on the right. So I would subtract. So this is a positive 3x. So I get rid of that by subtracting 3x. And whatever I do to one side, I do to the other. You can just easily do it the other way around if you wanted to. Those cancel out, leaving you 2 is equal to 5x minus 3x, which is 2x, minus 8. Then you want to get the 2x by itself. So you undo the subtraction of 8 by adding 8. Whatever you do to one side, you do to the other. Those cancel out, leaving you 10 is equal to 2x. You undo the multiplication of x by 2 by dividing by 2. Whatever you do to one side, you do to the other, leaving me 5 is equal to x. Over here, we're going to distribute first. 4 times k is 4k. Okay. 4 times negative 3 is negative 12. Minus k. We keep the k. Minus 6. Combine like terms. 4k minus k is 3k. Minus 12 is equal to k minus 6. Then when we get all the variables on one side, I have a positive k on the right side, so we'll get rid of that by subtracting k. Whatever we do to one side, we do to the other. Those cancel out. That leaves me negative 12 is equal to, 3k minus k is equal to 2k. We bring down the minus 12, and we also bring down the negative 6. Then we want to get the 2k by itself. We get that by itself by undoing the subtraction of 12 by adding 12. And we add 12 to the other side. Next, we end up with 2k is equal to negative 6 plus 12 is 6. We undo the multiplication of k by 2 by dividing by 2. Whatever we do to one side, we do to the other. That leaves me k is equal to 3. Let's try a few more problems. So over here, we distribute first. 4 times 4 is 16. 4 times negative 3x is negative 12x. Over here, we distribute. Negative 8 times x, we bring down the 32. The negative 8 times x is negative 8x, and then negative 8 times positive 2 is negative 16. We combine like terms. We have a positive 32 and a negative 16 over here. We rewrite the left side because that doesn't change. Then 32 minus 16 is 16. 16 minus 8x. We want all the x's on one side. Doesn't matter which. Let's say we want to get them all on the left side. So we undo this subtraction of 8x by adding 8x. Whatever we do to one side, we do to the other. These cancel out. That leaves me 12. And negative 12x plus 8x is negative 4x. And 16 is over here. Then we want to get all the constants on one side. So we undo or get rid of this positive 16 by subtracting 16. Whatever we do to one side, we do to the other. Those cancel out. We bring down the negative 4x. Equals 0, because 16 minus 16 is 0. You divide both sides by negative 4x. The negative 4 and the negative 4 cancel out, not the x. Just divide both sides by negative 4. And what that'll do is give you an x is equal to 0. All right, let's move on to this one. So first we're going to distribute within 5x. Then we go 5 times negative 3 is negative 15. Over here we bring down 5x minus 15. At this point we're going to try to get all the variables on one side, so we subtract 5x from each side. Cancel, 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 cancel. Then we end up with negative 15 is equal to negative 15. Next we're going to try to get all the constants to one side by adding 15. Whatever we do to one side, we do to the other. Cancel, cancel. We end up with 0 is equal to 0. And as soon as we recognize that these were equivalent to one another, we know this is an identity because something is always equal to itself. And since we know that something is equal to itself, we know everything that we can plug in there is going to make it true. So again, something is always equal to itself, which is all real numbers. Infinite number of answers, all real numbers are going to be the answers. And as soon as you recognize that it's going to be equivalent, you can stop. So right here we knew 5x minus 15 is equal to 5x minus 15. There's nothing that you can plug into the left side that's not going to make the right side equivalent because it's the same thing. So we subtracted 5x. Now we have negative 15 is equal to negative 15. Again, a constant is always equal to itself. That's always true. And then finally, if you get it down to 0 is equal to 0, you really need to recognize at that point, this is kind of a special case. It's an identity. 0 is always equal to 0. Infinitely many number of solutions, all real numbers. Okay, let's try this right here. So we distribute within here. So we say 2x plus 3 times x, which is 3x, plus 3 times 1, which is 3, is equal to 5x plus 4. Combine like terms. 2x plus 3x is 5x, plus 3 equals 5x plus 4. All right, so we want to get all the variables on one side. Minus 5x, cancel, 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 cancel. We end up with 3 is equal to 4. Let's try to get all the constants on one side, maybe, but it's really not going to work, right? So even if you do subtract 3, you'll end up with something like 0 is equal to 1. All right. So as soon as you recognize you have the same variables right here with different constants, you know that this is going to be a contradiction and this is never going to be true. So for instance, if you have 5 $1 bills and then you add 3 of 8 If you have 5 $1 bills and then you add 4, now you have $9, right? It's not going to be the same. Or what if you have $2 bills? So let's say you have 5 $2 bills, that's 10. Add 3, now you're at 13. Let's say you have 5 $2 bills, 10 plus 4 is 14. In fact, they're always going to be one off because the variables are the same, but you're adding or subtracting something different, which makes the end result different. They're never going to be equivalent. So as soon as you recognize that, you can stop. It's just going to be a contradiction. Next thing is 3 is equal to 4. Well, when is 3 equal to 4? Never. The same constant cannot be equal to a different constant. It doesn't work that way. They're constants. 3 is always 3, 4 is always 4, and 3 is never equal to 4. It doesn't work that way. I know that looks like a subtraction. That's not supposed to be subtraction. Okay. So those are two special cases. You want to remember that. Now, as far as no answers go, you have this weird little symbol right here. That basically means null set or empty set. It just means there's no elements to the set. There's no answers basically in this case.